Let's see here. Hello everyone. I am just trying to figure out where I am. Always click the start stream button before you actually know what you're doing. It's just generally a good way to go. So let me just check here. What do we got going on? Is YouTube working? Looks like it. We should get Twitch up here too. We're going to be looking at TypeScript today and continuing what we've been doing. We're up to objects.
Sokeman, Chevalier, Missionary.
Okay, so let's close all this other stuff. Okay, the titles look right. TypeScript. We have chat here. We just move that over here maybe. This can be a little smaller, no? No, the problem is the size here. Let's make this. Well, we're not going to stay on this view for very long. And I'm getting messages. All right. Let's find the right windows to open up for this. Ah, this is really ugly. This we will leave on this side so that we can have chat. And we can pop out the PeerTube chat because there's no way to integrate that into Restream. So I'll have that here. And I will pop out our chat. So I think this is now good. At least for me, it's good. Why is it gaming? I will mute my phone so you don't have to deal with that. All right, let's get started. I will switch over now. We will find a TypeScript web page. Here we go. Let's find it. Log out. Okay. How come I don't have anything here? Let's see what happens. I go here. Okay, we have nothing. So we'll just add the browser. Where are you, browser? Properties. TypeScript. All right. This is good. We are happy. The birds are singing. Except it's not letting me adjust the size for some reason. Like, what the fuck, seriously? Why can't I change the size? There we go. Close enough. And we are doing object types. All right, this is like starting it now. For real, for real. For real now. All right, I've been enjoying my TypeScript adventure. I thought it was going to be like a whole language, and it's not really. I thought that most things could like basically take TypeScript and run it, like there would be a TypeScript engine, but for the most part, it seems to me that it's cross-compiled, transpiled into JavaScript. Although someone told me about something called Deno, not D. I don't know how you say it, but it looks like it basically runs TypeScript out of the box. Open source JavaScript runtime. I don't. Anyway, I was gonna look at that later. JavaScript and TypeScript. WebAssembly runtime. Not really sure what it does, but we will learn this later. So let's try to get through some of this object type documentation and see where we're at. If you are interested in learning TypeScript like kind of along with me, but you missed the basics and these other parts here, then you can find like my previous live streams and you can follow along with them. Or once we finish like this last part here in modules, I'll make one mega video that has all of this put together and cut out all the parts where I'm just staring, trying to get my stream started. All right, so here we go. I say here we go and then I do something else, so it's not a very good look. In JavaScript, the fundamental way that we group and pass around data is through objects. Okay, great. In TypeScript, we represent those through object types. We've already done a few objects before. Kind of like this, right? Oh, we're going to need the TypeScript playground. Here we go. Okay. They can be anonymous or they can be named using either an interface. So we have an interface here for an object or a type alias. Okay. We might as well like make something here, right? Let's just get rid of all this. I don't remember what any of this is anyway. So we'll make an interface for I guess we'll make a creature interface. And here we don't use the equal sign. We'll have the ID, which is a string. I think it's a semicolon, or is it a comma? And we'll have health, which is a number. And we'll have the damage they do, which is also a number. Let's see if this can compile. So we'll have what's a good creature? A rabbit. And so we have to, why isn't it? We'll give it an ID. Cute rabbit. And we'll give it a health. Rabbits only have 20 health. and they do very little damage, right? And then we'll just have like, I guess we could just do console.log rabbit for now. Let's see if this works. There's no errors. We run it and we print out the rabbit. Great. We could have made this a type is what they're saying. Hey, God Madara. Hi, how are you? I remember you for sure. It's not like I have like 1,000 people chatting with me. I think I remember every single one. At least every single one that sent more than a couple of messages, you know? All right, so we have that. We have our little creature. Oh, I guess they pass it. We may as well like pass it. No, we won't do this yet. In all three examples above, we've written functions that take objects that contain the property name, which must be a string, and an age. So there's something that has a name and an age, and ours has ID, health, and damage, obviously. Quick reference, we have cheat sheets available for both type and interface if you want a quick look at important everyday syntax at a glance. Ooh. This looks nice. Let's put that in our gist. General, I guess we'll say here. And we'll say cheat sheet. Okay. Property modifiers. Why are you not responding on DC? Does that mean Discord? What are you talking about? DC. Oh, you mean like DMs? Did you send me a DM? All right. Each property each property in an object type can specify a couple of things. The property type, whether the property is optional, and whether the property can be written to. Oh, what would you like? What's going on in DMs? Maybe like I just didn't understand or something. Also, I can't actually respond to every DM. Otherwise, I would never get anything done. Optional properties. Much of the time, we'll find ourselves dealing with objects that might have a property set. In those cases, we mark those properties as optional by adding a question mark to the end of their names. Yeah, we've seen this before. And I think we did some stuff where we wrote get type code guards, overload rest parameters, destructuring. No, we didn't really write anything about that. So here we have this. And the type here will be or null, right? So paint options. Oh, interesting. In this example, both xpos and ypos are considered optional. So these two properties of paint options. We can choose to provide either of them, so every call above to paint shape is valid. All optionality really says is that if the property is set, it better have a specific type. Okay, or a set of types, right? I guess that's what they mean. We can also read from those properties, but when we do under strict null checks, TypeScript will tell us they're potentially undefined. So here you see it says number or undefined. So we need to make sure. So I guess we can kind of like model that in our code here. maybe damage is an optional thing, right? And object member. Oh yeah, it has to be here. So now we don't necessarily need to define damage that it does. And then let's say we have an attack function that takes the attacker, which is a creature, and the target, which is another creature. And let's say it returns the target creature after it's done. Okay, so here we go. We want to get the damage equals attacker dot damage. And here it's number or undefined. So if I just try to do this and do something like target dot health, I assume we have a minus equals attacker damage, and then we do return target, is possibly undefined. So this doesn't work, right? Print shape, and we just pass stuff here. Xpos 1, we can say shape. I see. They're just creating the object on the fly. Let's see what they continue to say here. So it might be undefined here. We can just handle by specially checking for it. If it's undefined, then give it this default value. Note that this pattern of setting defaults for unspecified values is so common that JavaScript has a syntax to support it. So here we're passing in default values within the object parameters. But I wonder if you're passing... I wish there was a way for me to do this without specifying the whole object, like to deconstruct. You know what I mean? Because when you deconstruct, you'll want like all the variables that you might use, and it's just a shame to like list all of them if you're not setting defaults. Here we used the deconstructing pattern for paint shapes parameter and provided default values for xpos and ypos. Now xpos and ypos are both definitely present within the body of paint shape, but optional for any colors to paint shape. Note that there is currently no way to place type annotations within destructuring patterns. This is because the following syntax already means something different in JavaScript. Oh, we can't like pass in this type annotation. In an object destructuring pattern, shape means grab the property shape and redefine it locally as the variable named shape. Okay, that's not what we want to do. I wish okay, so if we wanted to do that, right? Like we could do this and say deconstruct it here and do ID health damage equals 0, right? I think that's how it was done. Yeah. Comma, comma, and then just 0. And now we would just do just use damage. Right? And now this actually works, and now I can do something like our dummy target is actually a creature. Make a target dummy, and its health is huge. It has 100,000 health. Can you believe it? Why is this not happy? Because we have to assign it if it is a variable. All right, so we have a target dummy, right? So now we can do an attack, and let's give this guy's attack damage is equal to 0. He can't actually damage anyone. And can you deconstruct for damage only, I believe? Or is it not possible in TypeScript? Yeah, you can deconstruct for just damage. But then you won't be able to use ID and health is the problem, right? So if all I cared about was the damage, I could deconstruct it and do it. But imagine that I needed other stuff, like let's say that it had strength, right? And so now it's a required thing. So we do strength is 20. Or let's make it a modifier, right? So strength is 2 here, and strength here. The rabbit's strength is 3. And then so what we want to do here is damage times strength. Now, the issue is that strength is not optional, right? So it's just annoying that I have to list it. I wish I could just do something where I say damage is 0, but then I can just pull in the rest normally, you know? So let's attack something. We'll have the rabbit attack the dummy target. And we get back the updated rabbit. Okay. And we do console.log updated rabbit. It's not a rabbit, it's a dummy. Alright, so what should happen here? The rabbit has no damage. We'll make this easier to read. So the health is 100. The rabbit has no damage because we default to 0. Partial T. I don't know partial T. So maybe we just haven't gotten to it. If partial is a keyword, I don't know it. So we're defining a type that is a partial type from the full type, and that's what we care about. So it should do no damage when we print this out. So the target dummy still has 100 health. But if we now give the rabbit some damage here, let's say we make the default damage 10 and we run it. Now the health went down to 70 because we take the 10, we multiply it by 3, which becomes 30 damage because the rabbit's really strong, and it did 70 damage. But if we leave it at 0 here and then we gave the rabbit some damage, 1 point of damage, and we run this, then we'll see that it did 3 points of damage because it does 1 damage, but it gets updated with its strength modifier of 3. Yeah, we'll get there. Good luck. I am learning Spring Boot. Is Spring Boot like part of Spring, like Java Spring? Yeah, it's Java stuff. Spring Boot makes it easy to create standalone production-grade Spring-based applications that you can just run. Spring to me is so complicated, so when you say just run, it's sort of just like is funny to me. Like Spring just gives me like a headache. Look at how like, oh my god. These are all like products, right? Anyway, good luck with that. That sounds hard. Yeah. Is it for work, Manus, or is it like something else? Because that sounds tough. I wonder, yeah. Okay. Let's go back here. Note that the pattern here, unspecified values, we did all this. Read-only properties. Properties can also be marked as read-only for TypeScript. While it won't change any behavior at runtime, a property marked as read-only can't be written to during type checking. So in an interface, we can have a read-only property. I guess I should save some of this stuff here. Yeah, right? We should save some of this stuff because I'll forget all of this later. Objects. So one thing we know we can do is make default values. And this is something like function foo name comma damage equals 10. Note this uses deconstruction. All right, so we learned that. You optional object values in a type or interface, you can mark a property as optional with a question mark. Little optional properties. I feel motivated seeing you because you keep learning every day something new. Thank you. Well, I'm sort of built this way. There's some things other people do really well, and I suck at them. Really, 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 really suck at them. And I have a few superpowers, and one of them is I can read from the beginning of something to the end of something. That's like my superpower, the only one, which means that when I learn something, I learn it pretty well. But obviously, it takes more time. Other people just start like, let me just see how to do this, and then just look stuff up, ask LLMs. But that's not what I do. So, yeah, that's my thing. But yeah, and also I'm motivated because this is the language that I'm using at work. So, I kind of have to or should learn it better. There's that. But thank you, Manus. There's so much to learn, so many things. I just got a lockpick, um, and it's like one of those lockpick sets, and it has a clear lockpick. And I have like people inquire where I'm going. It's not like a religious choir, it's like, just cool songs. And when we sing, sometimes like I just have to sit and do nothing because it's the other voices that are learning their parts. Other people like are crocheting or knitting or they got their thing going on. Um, but like I tried knitting, I tried crocheting, I just don't like it. It's too much like you have to keep track of numbers, like, and then if you screw up, you have to start over. But a lockpick, I could totally just like play around with a lockpick all day. So I bought the lockpick, it'll come in a few days. And then while everyone's singing, I'll just be picking at my lock. We'll see what people say if they think I'm sort of like, what do you call those? People who like don't follow societal rules. All right, so let's see. Let's keep going. In JavaScript, even if the property has never been set, we can still access it. It's just going to give us the value undefined. We can handle undefined specifically for checking it. We did that already, right? We did all this. Yeah, we did this. How do we, oh, read, this is where we're at. So what's going on? They have a read-only property in an interface. And then I guess they try to write to it here and it fails. So they did it with an interface. Let's try it with a type. So we'll change this to a type now. And I think that's all you have to do to make a type. Let's make sure it still works. Yep, so now this is a type. And we're going to mark one of these things as read-only. All right, so I hope it lets us do this still. But now when we try to do something here, let's try to update the target.id is equal to damaged. And now it's giving me an error. Cannot assign to ID because it is a read-only property. There we go. All right. So it makes sense that this is read-only though. Once you assign the ID, it shouldn't really change. And I hope, like, you know, sometimes I really wanted to learn as fast as possible, but you see, like, I try to just use it while I'm learning. And in case you're the type that's like, oh, I gotta learn fast, like, maybe you can kind of just change your perspective and just be like, well, I'm gonna play with it while I'm learning. And when I'm playing with it, I'll learn better and maybe it'll also be more fun. I don't know, just a thought. Using the read-only modifier doesn't necessarily imply that a value is totally immutable, or in other words, that its internal contents can't be changed. It just means the property itself can't be rewritten too. So how can we change it with, how can you change a rewritten thing then? This is the same thing, right? This is the same exact example. We can read and update properties from home.resident. Oh, why is this available? Visit for birthday. Home.resident.name. So read only resident. I see, but we can change name. We can change age. But we can't change the resident property itself. Oh, that's really tricky. Right? You can mark a property in an interface or type as read only. TypeScript won't let you update that property. But it will let you update sub-properties. Right, so let's say objects are an array of IDs. And then I guess we should make a type ID here. Inventory ID is equal to number. And then we just say inventory ID. And we also have size of the inventory, which is a number. Right? Oh, I wanted to put this up here. Alright, so inventory is this stuff, and I can make inventory read only, right? And now that means I can do inventory, and I can make it have objects, which is an array, and I can make it the size, like how many max size, right? Let's say 10. So we'll do that. We'll do the same thing for our rabbit. It has the same 3 objects. It's like a bag. And now I'm going to try to edit our rabbit. Rabbit.inventory is equal to objects just one size 23. And this will give me an error saying, oh, oh, it's called inventory. Now our error is cannot assign to inventory because it is read-only property. But if I understand correctly, I can change size to 23. Holy crap, this is valid. And now let us print out rabbit just to make sure we understand what's going on. We'll comment this one out. And the inventory size is now 23. So yeah, this is kind of like not what I expect at all when you have a read-only property, that these are not read-only. So I guess I have to say that these sub things are read-only also. So maybe the objects can change, but the inventory cannot, the size cannot. And now it marks it as an error. You need to mark sub-properties as read-only also if that is what you want. I have to answer somebody. 1 sec. Oh crap. Did that show? Let me see. No, you didn't see that. but I should probably hide it. Alright, it's hidden. Hello, Blastoderm. I have a tip. Always declare variables using the keyword const or instead of let or var, so you won't have that variable reassignment by accident. That is a very good point. So if I change this to a const, the rabbit itself can't be a const because in a way I want its health to be updated, but I don't want its other properties like its ID to be changed. So now when I try to, let's see, so I make this inventory is read only, but the size here is just a number. So now I have a const rabbit, but it's letting me modify this rabbit, right? Like the strength. So rabbit.id equals ID is read-only. Let's just get rid of all this read-only stuff here. Okay, so I can't reassign a constant, but it doesn't mean that the object itself is constant, right? In no place have I been actually like reassigning rabbit. I think it's a good point that const is probably better than let, but it doesn't help me particularly with these read-only fields. Thank you. All right, where are we? It's important to manage expectations of what read-only implies. It's useful to signal intent during development for TypeScript on how an object should be used. TypeScript doesn't factor in whether properties of two types are read-only when checking whether those types are compatible, so read-only properties can also change via aliasing. So we have a person, and then we have a read-only person. For the object itself, we can use object.frozen. Oh. And is that a JavaScript thing? I think we learn about that when we get to classes, or I don't know where we learn about that. How do I type search for stuff in here? Static method, if it is frozen, freeze. Oh, it's called freeze. Hey Trina, how are you? Good to hear from you. Your streams are so late, I can't usually make them, but I try to watch them when I'm awake short for that brief overlap. Freezing an object prevents extensions and making existing properties non-writable. Okay. Interesting. It's funny how we have all of these things to make something const or read-only, but it's not like it doesn't flow through to its sub-members. All right, so what are we looking at here? We have an interface that's a person, And then we have an interface that is the same thing except it's read-only. And then we have a writable person, which we get, which is just a person. And we are able to make a read-only person from it. And then we're able to change the age. Okay. So that means that doesn't factor in whether properties on two types are read-only when checking whether those types are compatible. I don't understand that sentence, but I can kind of like imagine what they're talking about here. So we have creature, and we can make a read-only. This one is writable, and then creature read-only. And this one is like read-only version of all of it. Right? And what they were doing was they were making the regular creature. We have, and then we're able to make changes to the regular creature. So here, just like we did here, we run this now. You can see that we started off with a regular cute rabbit, but we've changed the name to new rabbit here. And we've also changed the inventory size from its default 10 to 23, right? So that was done. But what we're going to do first is make a read-only rabbit. What did I call it? Creature read-only. And we can say it is this rabbit. So that was fine. How do they do it? They had the read-only one, copy the writable version, and then they made changes. I see. So now the read-only rabbit is pointing to the right rabbit. We're going to make changes to the right rabbit, but now we're going to print the read-only rabbit, right? And you should see that the read rabbit was actually changed. So yeah, we changed it to have the new size and it says new rabbit. So even though the rabbit itself was read only, we were able to change stuff from underneath it. I guess this is a kind of a long example to show that, but how should I, what does this mean? This means that till now, do you like TypeScript? TypeScript is a development time language. It doesn't affect runtime, right? Blocks. Hello, how are you doing? Trina, I will be streaming tonight at 5 p.m. Eastern. If only I was a mod so I could post a link to my stream. What do you mean post, like if you're a mod on YouTube? You can't, what do you mean you can't post a link? Oh, because it doesn't let you post a link to the comments on my stream? Let me see how to fix that. I'm like streaming noob, even though I've sort of been doing it for a while. Alright. There, you're a mod, Trina. If you want to post a link, you can post a link. Alright, what did I miss here? Let me look back at this. TypeScript that has read-only, that protects properties and development time, but frees stops any editing to the object. Yeah, that's probably good to know. I will note it even though we didn't run into anything, but object.freeze will not allow changes, further changes to the object. This is really immutability, right? At that point. End blocks. I'm doing well today. I feel like now that I have a job, I gotta like do work, but in a way, like I'm learning stuff for my job, so I'm sort of working, so I don't feel too guilty. Um, so there's that. Adapting to like work life is hard when you haven't been working for like a year and a half or 2 years. How how do I like TypeScript? I think TypeScript basically makes JavaScript a lot more usable for me. I don't really know JavaScript, so I don't really know like what parts are TypeScript that I'm dealing with. Obviously, anything that goes into the type or interface or like that is TypeScript. But yeah, I like it. It makes me dislike JavaScript less. How's that? I still think that it is far from a language that I would ever want to select. Um, I really like languages that are well designed. So I don't mind Zig or Rust. I didn't program in Zig. I don't. But I programmed in Rust. I don't mind it. I prefer functional languages, but I can use, something like Rust, and I think I could use something like Zig. But here, there's JavaScript just has so much messiness, and I think it's just because it was kind of hacked together in the beginning, right? Um, so there's that. We can also mutate the rabbit object using its read-only type. TypeScript will complain. Yeah, it'll still complain. Yeah, yeah. So it'll TypeScript is basically like warnings on annotation, right? It doesn't like stop us necessarily. I guess like you can set compiler options that say like don't basically compile or cross compile if there's errors, but um there's your thanks for posting, Trina. Very, very kind, all of you. I will be back. Need to run some errands. Good luck. Have fun. I love JavaScript too. I use JS syntax in order to mimic TypeScript typing within JS. Yeah, I have to learn that whole JS stuff. I don't know it. But thank you for helping me from someone who knows JavaScript and maybe TypeScript a lot better. Okay, where were we? Wasn't I trying to type this here? Because here, right, the read-only stuff can be tricky because what's happening here, the read-only only applies when you use a reference that was marked read-only. If you have another reference that points to it that isn't read-only, then you can do whatever you want to it. And that's just because the two types are basically the same, right? How do they call that? They said it here. Just want to clear this, think clearly in my head. Types, two types are still compatible, even if they differ with regards to read-only for read-only properties. Now, even if one has read-only properties and the other doesn't. It's not quite true, but it's close enough. I think you get the point. This means that the read-only check can be bypassed if you pass in a compatible type that isn't read-only. Example. Here's my way too long example. Two types are still compatible. So we have these two types that are compatible even though one has read-only, the other one doesn't, or at least not all of them. And I can actually get rid of dummy target. But anyway, because we're copying the read-only to Rabbit, you would expect read Rabbit to never change, but it does change because you have a reference to the same object through the non-read-only type. Completely different names would have the same structure. Right, exactly. Yes. You're so brave. I couldn't learn it in front of everyone. Too shy. You know, it was hey Garrett G also welcome. The thing about learning it is when I started streaming, I had this whole thing about like I wanted to prep a little bit, make sure that I wouldn't be totally lost. If you see my when I did COBOL on a mainframe or Atari 6502 programming, like those are much more dangerous because like it's I'm running an emulator. I might just get so stuck that I can't continue, right? And it's such old technology that I'm looking at like super old docs from like the 80s to kind of figure it out. And sometimes I'd be stuck for an hour or two on stream. And like it sucks, right? But I guess I try to remember that this is how everyone learns and I think it's good for people to see that it's not just them that struggles because we have this weird like social network view that people just learn really fast everything they see. But no, sometimes you just get stuck. And the other thing is like, well, I'm doing this for me too, right? Like you guys really help me just to stay on target and learn. I have ADHD, I'm autistic. It's like otherwise I just get like deregulated and I want to do something else. So since I pushed the stream button, I kind of like want to finish a little bit more, you know? So it really helps me. Um, in terms of languages, I know Python. I've used Python. I've used Python for work, but as soon as I use it, I forget it. The languages that I'm best at are Elixir. That's the one I use mostly whenever I have to do anything. I guess I know Rust. Used that more recently. And made projects with it. But yeah, I know languages like Java and C Sharp, C++, but I just haven't used them in a long time. So Elixir, maybe some Haskell. Those are the languages I mostly use. So if I were doing front end stuff, I'd probably use Elixir with Phoenix Live View, or maybe I use Gleam, or maybe I would use PureScript. I don't know, or Svelte. I know Java, but I'm not very good. I'm not very good at Java anymore. I forgot a lot of it. It's so annoying. Where am I? We did this already. Using mapping modifiers, you can remove read-only attributes. Whoa. Where is this from? Mapped types under object type. So this we get to this later, I guess. In type manipulation. So we won't look at that yet. Index signatures. Sometimes you don't know all the names of a type's properties ahead of time, but you do know the shape of the values. In those cases, you can use an index signature to describe the types of possible values. For example, what the hell am I looking at? Interface string array. index number string. What? String array. So my array is a string array. What? Above, we have a string array interface which has an index signature. This is an index signature, I guess. This index signature states that when a string array is indexed with a number, it will return a string. Okay, so indexes are always in an array, right? It's always in an array, and you just tell it what it's going to return. TypeScript won't complain much. I'm taking Java 2 in uni right now. Oh, good luck. So yeah, let's see. How are we using it? They don't say get string array, so I guess we don't know how it's constructed. But we know that when we pass in a number, we get back a string. So what do they do when we click try? Are they going to show us how they make it? Yeah, this won't actually work, right? Like, I can't, it's not like a working example, is it? Yeah, like, we don't know how to make one of these. I hate these examples where they don't actually give you something that will actually work. I guess we'll get to it shortly. Above, we have a string array interface which has an index signature. This index signature states that when string array is indexed with a number, that is done over here. We have the string array indexed with a number, it will return a string. So this thing, you see it says second item is a string. Only some types are allowed for index signature properties. String, number, symbol, template pattern strings, and union type consisting only of these. Okay, so we can only, for this here, this part where it says string, it can only be string, number, or symbol. Like basically the built-in fixed memory types. It is possible to support multiple types of indexers. Note that when using both number and string indexers, the type returned from a numeric indexer must be a subtype of the type returned from the string indexer. This is because when indexing a number, JavaScript will automatically convert that to a string before indexing it into an object. That means that indexing 100 a number is the same thing as indexing 100 a string, so the two need to be consistent. Interface animal has a string. Interface dog extends animal has a breed, so dog has a name and a breed. And now we have interface, we have an indexed, is that what it's called? Indexed signatures. So here's an index signature where we are returning an animal. And we have also a string returning a dog. And I guess because it will turn a number into a string or something, these two, you can't have both. Right. Thanks, Blastoderm. While string index signatures are a powerful way to describe the dictionary pattern, they also enforce that all properties match their return type. Right, it's all going to be of one type because you're saying that it's always going to return an animal, for example. This is because the string index property declares that obj property is also available as obj property. In the following example, names type does not match the string index type, and the type checker gives an error. So we have a signature index. It says it takes in a string. It's going to return a number. Length, number, name, string. Property name of type string is not assignable to string index type number. This is because we said number here, so it can return length, but we can't return something else. However, properties of different types are acceptable if the index signature is a union of those types. Right, here we have it as a union. Commander, oh man, I don't think TypeScript is a good place to learn about types. What do you mean? So if we play around with this, I guess you can think of index signatures as sort of like a map type, right? Where all the return values are going to be the same. Well, yeah. But you know, you got to learn TypeScript if you got to use TypeScript. So we'll make an age book, which is going to which has basically, I guess we can make it an indexed where we give it how is this syntax? Index. Let's call it index. We give it a string, which will be basically the name, right? So we do type and this returns a number because it's going to return you the age. What? Oh, I typed string. There we go. Okay. So we're okay here. And now we're going to return the age. So there can be like age is a number. And something is an age book. So does that mean I can get age, which takes in an age book and returns a number? Does that mean I can do age book? I want to give it the name. This is how this would work, right? Index signatures. There we go. Yeah, if you learn a thing from a bad example, etc., etc. Well, yeah, I mean, I'm not sure what you mean. Like, I've used other languages other than TypeScript, so I don't think I'm learning types from TypeScript, but I'm learning how TypeScript does types, and so there's that. I don't poorly designed system. It's a little bit like what I don't know that you could do more on top of JavaScript. I guess we'll have to just, you know, if I were to design a type system over JavaScript, how would it be different? I don't know. But I think having, well, yeah, I think a lot of this would still have to be the way it is. I've seen it quite people, yeah, checks out. Index can only be number, right. We've read that. So name is an alias for string, right. Yeah, that's how it's working here. I just feel weird, like, from Elixir, it's kind of like using type as documentation, so it's a little bit nicer for, I hate to just say index string. It doesn't tell me what it is, so this just makes it clear to me. Yeah, it's just important that your first experience is not JavaScript or TypeScript, for sure. I think I agree with that. TypeScript, if you're going to go into a highly statically typed language and want to learn a type system, I think TypeScript would probably be confusing. You'd learn not the ideal system. Like Haskell is probably the best example of a type system. It's beautiful, but yeah, TypeScript's probably the worst. Well, JavaScript's probably the worst, but I don't know how JS docs work. All right, so let's keep going. The only issue here is I wonder how to build one of these age books. So how do I implement this type signature interface? Will they show me? Do I just is it like an operator? You can make okay, let's just keep going. We'll see how it goes. Finally, you can make index signatures read only. Sure. I see. This prevents you from assigning based on the bracket operators. Why don't they just show me how to implement this? All right, I'm not a big fan of LLMs, but this is really bothering me. So I'm just going to ask some LLM to help me with this. All right, so let's go ask Claude. Where was it? I want to implement HBook. Oh. It's just an object. That's all it is. So you just have to have the property in here. You see, if they just fucking gave this to me, maybe this is a JavaScript thing that people just know this, but this annoys me. All right, so we have an HBook. You have to have the property in it. And then otherwise, you just give it like, it's just a dictionary. So now if I made this like foo, this is going to give me an error because string is not assignable to number. Oh, this is awesome. Because if this was just a property, this is fine, right? You see that? This is fine. But, oh, right. But like, it's not fine when I make it an age book. Um, why? Equals age book. What did I just change? Oh, no, it's because I did it wrong. Age book equals, and now this is wrong because it's saying it has to be a number. So let's make it, Bob is 11. So when I call get age now, okay, so now when I call get age, I give it my age book. It's kind of like Facebook, except it returns ages. And we want to find the age for, this is actually wrong, isn't it? It doesn't really return a number. It doesn't always return a number because you can pass a name that's not right. So let's find out John's age. Wow, I'm using crazy typing here. I mean, case. And then we do console.log John's age, right? So John's age is 30, so it should print out 30. I use chat. Wait, what did I miss here? You guys are so chatty today. I love it. I never advise anyone to learn TypeScript before JavaScript because you'll be unable to identify when something is pure JavaScript or it's TypeScript. Yep, I guess that's me. I kind of know JavaScript though, just as vague, use it a bunch, but I wouldn't say I know it. So some of this is annoying, but it's so similar to other languages that it's not too bad. I'd say overall JavaScript like third or fourth. Yeah, I use Chat AI all the time, but I mostly use Microsoft Bing version. Claude does really well with code, like, so I do that. But I'm kind of like trying not to use too much AI, LLMs, because I feel like the whole point of me, how I learn and take pride in stuff, is that I want to know how it works. So, yeah. I also think a lot of people who just use LLMs all the time, they're just going to like, their brain's just going to work a little differently and they can get stuff, easy stuff done really quickly, but like the harder stuff's just going to be out of reach. TypeScript is very good at inferring return types so we can be lazy. Yeah, I agree. I think type inference is really good. I do think that like when you do assert it though, sometimes like you're like, oh, it's really good at knowing it, but like when you assert it, you can get an error right away and it shows you, and it also can help just from reading the code sometimes, you know. So let's run this. Yeah, it says 30. Okay, perfect. So now we have an end-to-end example of how to do this. The only weird thing is if I put in like Jacob in here, it says undefined, and I got no error here that said this is like possible. You see, like I said number, but really here this should be number or undefined, right? And now it at least will give me a warning here that it could be this. Yeah. So What do you guys do here? Do you just go like... No, this should be in here. Age is equal to undefined. Then return 0. Is it this? Or return age. So let's do it this way. Now when we run this, we get 0. Yeah, it's still not, it's too bad that it doesn't know. Like other languages would kind of know that this is not. It did return undefined before when I just said number and I just did this. Maybe we would do it this way. It kind of depends how our actual code works. We'd probably throw a runtime error actually. But anyway, so this is type signatures, index signatures. Let's just save this. And my summary of index signatures is basically going to be, if you want a dictionary, that's all the same types. Basically maps dictionaries with all the same return type. All right, so we have that. The gist here, I'll put it in here in case anyone wants to look at it. You can drop undefined return type. Yeah, I dropped it. And define age book with well-defined property instead of index name number. I guess whenever you have a map, you have to think that the map itself may not have the key that you're looking for, right? So, in a sense, it needs to signal that somehow. Excess property checks. How long have we been going on? We're at an hour and 20 minutes. Can you believe it? Time flies. Like, literally, if I study alone, I'm like, after 20 minutes, I'm like, oh my God, what am I going to do? I'm going crazy. But like an hour and a half can go by so quickly. You guys should try streaming. Just click stream. No one cares. Just try it. It's like, don't be too shy. Just do it. You don't need to show your face. Excess property checks. Yeah, even if nobody comes, who cares? Where and how an object is assigned a type can make a difference in the type system. Although it's super helpful when you have people that can help you with things, you know? Because you were complaining that AgeBook wouldn't error when accessing a non-predefined type. Yeah, exactly. I think I agree with you. I kind of like updated how I'm thinking about it a little bit, but I agree with you. What is this saying? When and how an object is assigned a type can make a difference in the type system. Oh, where it gets assigned a type. One of the key examples of this is in excess property checking, which validates the object more thoroughly when it is created and assigned to an object type during creation. So let's see what's going on here. We have an interface, which is just like a type for the most part, and it has two optional properties, color and width. And now we're going to create a square, but it takes in a config. So this is the config, right? So it's going to make a square based on the color and the width. And it's going to return an object that has a color and an area. So here we go. Return color. If config color, it's going to be config color, and if that doesn't exist, it's red. It's nice to know we can just like OR this. Config width. Oh, so I didn't have to do undefined in my code. I can just do age like this. Oops. I guess not. Okay. I guess that's the difference of undefined versus... Does this work? No. Better to be explicit, I guess. Width. So if width exists, then it's going to be the config width times config width, because it's a square, their two sides are equal. Otherwise, we give it a default area of 20. Let my square create square. We give it a config where we pass in color and width. But they spelled color wrong. Why? Well, they use British here and American here. Object literal may only specify known properties, but color does not exist in the... Did you mean to write color? Yeah. This is just what I would expect. Notice the given arguments to create square is spelled color instead of color. In plain JavaScript, this sort of thing fails silently. Yeah, it's type checking because you said that this takes in a square config. So whatever it gets passed in should have these properties, right? So that makes sense. So you ask Empathy Monster, do I have a system for keeping track? That's exactly the link I sent earlier, this gist. So I just keep track of things for each section that I think is going to be useful to me. And I write it in ways that I would understand it. So here we're learning objects. I've been writing stuff in here that is useful for objects. Square config isn't an open-ended type, but optional known types. Right. Because it says that here are the types, but they are optional. Hey Trina, welcome back. It's not using that prop string type syntax. Yes, exactly. It's not a index signature. You could argue that this program is correctly typed since width properties are compatible, but there's no color property present and no color property is, and the extra property is insignificant. However, TypeScript takes the stance that there's probably a bug in this code. Object literals get special treatment, undergo excess property checking when assigning them to variables. I see what it's saying. If an object literal has any properties that the target type doesn't have, you'll get an error. Right. This is what most languages do, right? So maybe JavaScript doesn't do this, but this is what I would expect, and that is useful. Getting around these checks is actually really simple. The easiest method is just to use a type assertion. Oh, and this is now saying, I don't care what you think. This is a square config, even though I'm not passing color. I love it. I love it. So is that as simple as I have a function here, attack that takes two creatures. Now can I just pass in let's call this out. So here we go. Now I'm passing a guy here. Object literal may specify only known properties and food does not exist in type creature. Right, so it's saying this is bad. But now I'm saying, whatever, I don't care. This is a creature. No, that doesn't work. It doesn't overlap. So what if I had ID here? Overlaps. Now if I have strength, I see. Because these two are optional, you can pass in extra stuff, but you still need to meet the minimum. So I could pass in extra stuff here, right? ID. Inventory is a pain in the ass to write. Strength, health, damage. Where am I going wrong here? Creature has ID, strength, health. ID, strength, health. And here we have ID. You need to use as any as creature. Inventory. Isn't that weird that I have to do it twice? Here's this as creature. ID needs to be a string. There we go. That works. So we see here, this works, but now because I have as creature, I can actually get rid of this and it should work, right? Because this is exactly what this type is compatible with creature. But now I can add extra stuff in here. Like, let's say I pass intelligence and its intelligence is 12. It's going to say, oh, this one I don't know about. But now if I say as creature, it's going to ignore that and allow me to pass it in. So let's see what's happening here. This will kill the the dummy target has 100. So when we run this, it should have a health in the negative. Yeah, see, it has a negative 9,000. It got one shot. Oh, if you want to hack it as anything, yeah. If you typecast it to any, then sure. But I hope I never have to do that. But I'm sure that in practice you do. Here I am just using the excess properties. So I'm basically adding an extra property in here and I bypass the check. So we can probably just like take this code here and show and use this as an it's shorter than my example, because here we are passing opacity, which is an excess, what's it called? Excess property. Use as to bypass strict checking. Okay, so here we go. We take this, put it in our thing, and it's called excess. I don't remember the word. We'll look up the word and fix it. We'll just go back. It is called excess property checks. Excess property checks is an excess property check which triggers an excess property check. Use as to bypass strict checking. There we go. However, a better approach might be to add a string index signature. Again, string index signature. Not again. If you're sure that the object can have some extra properties that are used in some special way. What? I see. So basically they're making a map here where the map has some properties that are basically need to be in the list of properties whenever you make a square config. In a sense, even though they're optional, it can do some checking for it. Yeah, it can do some checking because it's still going to consider this as a closed type. It's kind of open because of this string. If you pass an extra property that is a string, then I guess like it can't know, but if it's not, if it's something else, it'll give you a type error. So let's think about like, here was our type signature, right? Um, so if we wanted to make this a config, let's take their code and try to make it work that way. This is a good exercise. Overcoming excess property checks. All right, so we obviously missed something here. Create square. There we go. So this one has color that's not, it's not happy about. So what we're going to add are a few properties that includes, no, the example we wanted to give was opacity. And opacity is not in this list, so it's not happy with it, right? So we're going to say we're going to make an index property, which always starts with brackets, and it's going to return some value. So it's going to be a number in our case because we're making squares. And the index is a string, right? So we're going to make index and it is a string. Uh-oh. Yikes, we ran into problems very early on. Unknown. Oh, it's because all these things have to be the same value. That's why. No? Alright, because it's optional, like if these weren't optional, I don't need the undefined here. Right? This is fine. I'm reading chat. The unknown type is similar to type any. However, if type is unknown, we have to do a check before TypeScript allows us to use it. Got it. That's another type that we need to keep track of. Unknown. Where was it? Here. There was also like a never type. We don't have it here. These are all super annoying types, like annoying as hell. Alright. Annoying as hell. All of these are like basically saying stuff that's complicated. But anyway, so what I was saying was, because the square config could return a string or a number, we have to have both of those. But since they're optional, we have to also include undefined. This is going to limit our future possible values to always be string or number, but I'm fine with that. Yay. Tell us how you really feel, seriously. So what am I doing here? Right, so now we have this square config. We're using it here. But we're not making any square config. So here we're going to have to create square. Here we go. We're calling a square config now. Opacity 1.5. I see. So now opacity fits in with this index string. Why do I feel like my age book is different? Oh, all of these, this is basically saying name can be a number, but here I'm basically saying I have a map of properties. So I can have as many as I want here. Like, I can have shininess to be 2. And I can just pass these all to create square, right? These are all optional properties. But I couldn't make this, let's see, you have string, number. What other types were there? Boolean. I can't make this a Boolean because you see all our optional types need to be string, number, or undefined. So this has to be like this, or it could be, true, because it could be a string. That works. And funny enough, can I do this? I can even do this, right? So now it's going to create a square. It's going to look at this stuff, and it could optionally look at config dot opacity color area. So we can take area. I know this doesn't make any sense like from a math perspective, but we can just add opacity to this. No. Oh, it doesn't know if it's a number. So we have to do we gotta do something like this. If type of is equal to number, then we return config.opacity, else we return 0, right? So now opacity is a number, and now we're going to add opacity to it. Here, let's make this a little bit easier to read. Plus config.opacity, otherwise return 20 plus opacity. Not config.opacity, just opacity. Okay, why are we not happy? Why are we not happy here? Prefix it with plus. Prefix what with plus? Alt plus config.opacity 20. I see. But why is this not working? It's a syntax error that I'm not understanding. Maybe we just don't need this. That's it. It's just because we don't need it because it is within an object and I was just being stupid. So here we go. So we have what should happen now? Let's see what happens. We're going to give an opacity that is 0. Actually, let's give no opacity first. We'll now print out my square. Right? So let's run this. So why is my square... God damn it. We have too much stuff. Let's get rid of these console logs so we don't get confused by them. Alright, run it again. There we go. Color area is 10,000. Does that make sense? Let's see. The config we gave it said we sent in no color, right? So the color default here is red. We can change it to blue. And then when we run this, it says blue. Now, configuring the area can be a string or a number. If we prefix it with plus, TS will encrypt it as a number. Oh, that is cool. But I thought plus could also work with strings, no? So let's figure out, how does it do area? Area is basically looking at the width. So it takes the width times the width, so it's width squared. Width here is 100, so it's 100 times 100, which gives you 10,000, right? So now if I pass an opacity, it'll add the opacity to it, right? So I'm going to add opacity. Opacity 10. No, 3. So now the answer should give us 10,003, right? Let's try running that. 10,003. So there we go. So we are able to overcome this. What you're saying is I should be able to just do like this plus. Will this work? No, that's not happy with that. How come this doesn't work? I put a plus here. Oh, maybe it needs to be together. How come this doesn't work? Because it's possibly undefined. But I will put this in our gist. And this is an example of... what was an example of? Using index signatures to overcome excess property checks, sort of. I feel still very uncomfortable with these index signatures for some reason. It just doesn't like want to stay in my head. Like I would never use them. Isn't that weird? I guess TS is becoming more strict. Yeah, it's probably more strict. I also have several flags running here. Oh, we're using ES next. We're using like the latest stuff. So I have all of these all these strict checks. Maybe that's why. We don't need it. All right. Well, let's finish this little section and we will. Where the fuck? Why are we still doing this? How do we end up here? We did this. We did this. We did this. Okay, here we go. I'm trying to like integrate what we just did in my head. So you can have an object, and when you pass it as a parameter, it can have many different properties, obviously. And it's going, if you type that object, it's going to check for type compatibility for that object. And if you have any extra properties that you pass, it's going to say, hey, you have extra properties. That's not legit. For some reason, and this is where I guess like it just doesn't make sense to me, you want to bypass that excess check. You want to basically pass excess properties. In general, I just wouldn't do that. I just wouldn't pass excess properties, or I'd pass it kind of like a map. And so what it's doing, what they're saying is like, if you just add an index signature into an object, now you basically have a map that's implemented within your object, so you can pass in anything else. So it's kind of like a trick. All it's doing is adding a dictionary into your object. But it'll still do some type checking to make sure that the return type of that map matches the other values that you have in your object already. It's their types. So that sort of makes sense. It still doesn't want to stick in my head. It still doesn't want to stick because I just don't ever want to pass excess properties. I guess you can think of it as like extra parameters to a function. But those can be better type checked. So anyway, I'm going to stop thinking about it. We'll just keep going on. One final way to get around these checks, which might be a bit, it's funny when like the type system is trying to tell you how to get around itself, which might be a bit surprising, is to assign the object to another variable. Since assigning square options won't undergo excess property checks, the compiler won't give you an error. So we just pass it to some other variable, and then we, wait, what? The above workaround will work as long as you have a common property between square options and square config. Right, we saw this before. In this example, it was the property with. It will, however, fail if the variable does not have any common object properties. I don't like this, but yeah, I don't like this at all. That basically you can pass all these objects with excess properties. I think in a previous stream when we were doing this, I was like, what the fuck? Okay, got it. If something can be a string or a number, prefix it with plus, and it will infer it as a number. Got it. I guess that's changing a little bit. Basically, we can have properties that must exist or they're optional parameters. We can also declare the type as being open-ended. which will allow us to add extra properties that are not predefined. JavaScript is a very flexible language. We can add, delete properties from an already created object super easily. Yeah, it's like it's superpower, but it's also like the reason why TypeScript exists because we've given you guys too much power and you guys abuse it, and it's really hard to find bugs. That's why TypeScript has that property string type syntax, so objects are open-ended, right? Yeah. All right. Well, we're getting to extending types, and we've been at it for exactly 2 hours and 30 seconds. So we're gonna break here. We're about halfway. I don't know if you guys, yeah, you guys can see it. It's about halfway. So we'll do more hopefully tomorrow. And who knows? But thanks for being here and keeping me company. It was really helpful. I learned a lot from you guys as much as I learned from the documentation, so that's really useful. If you want to know like when the streams are happening, you can find in my bio on wherever you are, like you click on my bio link, you'll see Blue Sky and Fediverse links. I usually just send a quick message saying I'm starting a stream if you care about that stuff, or join Discord and the bot automatically pings the a channel, a role for it. Um, but yeah, because I don't really have a set schedule like when I start, or sometimes it's around now, sometimes it's early, sometimes it's late at night. So I'm in Paris time, so it's 4:30 here. Thanks for hanging out with me, everyone. I really appreciate it. It was really cool. We learned stuff. I learned stuff. I don't know about you guys, but that was a lot of fun. I'll be getting back to my other languages soon, but have to finish TypeScript because that's what my job uses. All right. See you guys later. Bye. Yes, and check out Trina's stream also. I try to make it, but 5 p.m. Eastern, 6 hours later, that's 11 p.m., right? So maybe I can like watch some of it. See you later.